Yeah, hi, my name is Elliot. First, thanks for joining us here. We hope our presentation helped inform you in either practice or research, because what we do is sort of straddles both, and we like it that way. So I'm an assistant professor of computer science education at Montclair State University. And
hi, everybody. I'm Pooja Addla. I'm a UX researcher at Viasat, also formerly from Teachers College Columbia.
yeah, so the research here, as well as the paper actually that we wrote for this, we did while we were at Teachers College. All right.
Alrighty. Okay. Like Elliot said, thank you all for skipping math workshop and being here. That 15 more people than I was expecting. So, but anyway, so why study behaviors in the first place, right? Well, research has shown that proximal contextual factors such as, say, negative classroom environments or discouraging language affect students' ability and interest in STEM to succeed in STEM by affecting their confidence. I mean, duh, right? Like, how many of you have been in some kind of like a science or math classroom and questioned if you belong there? Yeah, I certainly have. And historically, females and minorities have been more adversely affected, right? So by observing student behaviors in STEM settings, we can get insights into their like motivations and self-efficacy, that is their ability to succeed in that subject. Understand their willingness to learn, their curiosity, like are they asking questions about what they see? Are they trying to like experiment outside of the experiment and things like that? And also like these behaviors can serve as evidence for learning.
So I apologize, I forgot to even like talk about the title of our paper. What we were very interested in looking at is how do students behave when they're in virtual reality lab settings. As you know, things have just kind of been pushing this way, and we feel like in the future this is going to be something that is often probably going to happen more regularly. And so we think it's very important to note that the behaviors that students may be exhibiting in these kinds of simulations should be well understood, and they may not kind of present in the same way that you would see in real life lab experiences or hands-on experiences for science. So these are the research questions that we were looking at. Specifically, we wanted to note just general kinds of behavior that they were exhibiting, and then also from their own perspectives, how did they perceive that learning experience, and if they both enjoyed it as well as if they actually felt like they learned something from it. So our sample population was 76 students, ages 11 through 18. The study happened predominantly in after-school programs, as well as summer camps at a local community center. And 97% of the students were of African-American, Latino, or a mix of both of those races. Self-reported genders were pretty equal, and in terms of sort of age differences, most of the students were middle school age kids, and that was mainly due to just the makeup of the students that went to these programs. In terms of the flow of how the study went for any participant, we would first have them go through just a demographic questionnaire, which asked the pretty standard questions, age, gender, as well as familiarity with virtual reality, and they would select, how many years or non-years they were experienced with using VR. Then they would be shown a 5-minute lab safety video that we created on our own, kind of spliced it together from a more regularly used lab safety video from the American Chemistry Society. Then they would do the VR chemistry lab simulation that we had. And then after that, it was a debrief interview with one of us. In case someone wants to know, because somebody always wants to know what exact chemistry thing they did, I put this in there. It was a double replacement reaction using copper chloride and aluminum. But most people, again, don't really always need them. Someone always asks, so I'm just gonna put it out there. If you are a practitioner, it actually satisfies one of the next generation science standards, which was partly because the goal of the lab simulation that I created for this actually is meant to be something used by high school teachers or middle school teachers, homeschooled families, things like that. And then in terms of how we measure the behaviors, most of the lab safety behaviors were all like one-time kinds of things where you had to basically observe them, and you could mark if they successfully did it or not at the right time, right? So for instance, wearing lab safety goggles, did they put those on at the beginning of the experience, or did they put them on after they messed with chemicals and things already, right? And so the first way would have been a successful experience or a successful action. The second method would have been not successful. And then for this novel behaviors category that we are going to be talking more about, we looked at basically the amount of time in seconds that they engaged in a specific kind of activity. For instance, like just running around or moving around and practicing teleporting and things like that. We would time how long they did that, as well as if they did it multiple times. And if they did it multiple times, we just added all those times together. Okay. So here's a video of the experience. And as you can see on the right side, you have sort of like an external view of one of the students doing it. And on the left side is her internal view. The lab simulation, which I tried to make it basically as close to reality as possible. It has all the typical safety things that they would use in a chemistry lab, as well as like a working scale and working sink, for that matter. But the idea again was to have this be a way to simulate a virtual reality, or in virtual reality, a chemistry lab experience. Okay. And then here's a video of a student doing mostly these novel behaviors that we talked about. So as you can see, he basically just wanted like practice breaking everything that I put in there. And I had purposely, again, coded the glass beakers and flasks to break and to create, broken 3D models, because I wanted to actually see whether or not students would sort of engage in this kind of activity when they first experience these things. So these are all different kinds of or examples of the non-learning behaviors right, that you would typically see. He actually at that moment threw my physical Oculus Quest controller across the room, and it was like super startling. And I was like, "Oh my God, we just started this study and you broke my VR." But thankfully, it was okay. Yeah, and typically, teachers or educators would see this kind of behavior and just kind of feel like it's disruptive, or he's not really learning at least what they expect him to learn. But as you'll see, we interpret this kind of behavior as something that kind of leads to more curiosity and interest in science stuff. So, and Pooja will get more. We'll get more into that. But first, some of the results. So we looked at basically the three kind of major ways that we could categorize the students in terms of age, gender, and familiarity with VR, and looked for any correlations between these categories of novel behaviors and and if there was a correlation with any of the categories here. So just to make it easier for people to see, we had two findings that were of significance where there was a positive correlation with the familiarity that students had with VR, and if there was a higher chance of them interacting and just playing with the Bunsen burner and the fire extinguishers, which again we'll talk about more later. And as for another interesting result, we also look for this significant differences between males and females, and in turn with how much they practice lab safety behaviors in this virtual reality lab. And two things that showed significant differences were For wearing the safety apron, which if you remember, kind of had to walk over to a different area and grab it, and cleaning up messes at the end of the exercise. Which if you think about in a virtual reality lab, at the very end of it, many students would probably just be like, oh, I'm done, but there were a significant difference between girls who were like, oh, I'm just going to clean up things and tidy up, versus like boys who just let it all stay that way.
It explains why men are 3 times more likely to be killed from risking.
Yes, exactly. Yes. So, but I mean, these were only 2 of the sort of safety behaviors that did show that significant difference. There were other ones, all of these actually are safety behaviors that we looked for, and in many of the other ones, there wasn't a difference there. All right, so. Okay.
Alrighty. Oh, you guys should have been there. Like to see the excitement on their faces the minute they took off their headset, they were just like, "Oh my God, this is so cool!" And the minute they knew this guy made the game, like through the roof. Yeah. So all of these quotes, the thought bubbles that you're seeing here, are actual quotes from the participants. And like, yeah, most of them use words like "cool" or "impressed." And depending on their like prior experience with VR, like some of them were kind of like confused at first with like using the handles or like yeeting them off the room. But like other people also had like some trouble like with the spatial orientation in the VR, but they quickly got the hang of it and really owned their experience. And earlier I talked about self-efficacy and how self-efficacy can help predict like future like choices, STEM related choices in terms of like academic or career choices. And we were thrilled to hear that a lot of participants like felt like a real scientist, and that's what we were going for. And they really liked that they gained a lot of like practical, like real world knowledge about like how like science labs work, especially like more of the younger kids, and just that whole experience of like using those equipment, things like that. Alrighty, I can hear your stomachs grumbling for lunch. So we'll move ahead. What have we learned from this experiment, right? We believe that these novel behaviors exhibited by these students show the curiosity and just their willingness to explore. Like I was talking to Ian earlier in the other room, and he used the analogy of like sandbox and just letting the kids play, right? And in real life lab settings, like these behaviors are rare, but in our experiments, like 51% of the participants demonstrated these novel behaviors. And this VR simulation enables students to explore and engage in these behaviors, in a safe setting, monitored setting in a virtual environment, which is for typically like taboo kind of things like the throwing the beakers or like, turning on the Bunsen burner and things like that. So this provides them some autonomy over their learning and continues the cycle of like curiosity and willingness to like engage with like STEM subjects. Let's see. Oh, and also like Elliot mentioned, a lot more of the female students were like demonstrating more cleaning behaviors. But research has shown that in real life, female students end up like deferring to like male students to handle a lot of the equipment. So this has shown us that we've got to start encouraging our like female students to like, be more hands-on in physical labs and teach our boys to start cleaning up their own messes, like first and for all. Let's see. Again, like we mentioned, we were really happy to hear that a lot of them felt like a real scientist, and they demonstrated that their interest for STEM really grew after this experience. Maybe in the future, we can conduct some longitudinal studies to see if these novel behaviors transfer from the virtual labs all the way to the physical labs as well. And if these positive feelings that they experience after, playing around in the virtual chemistry lab increases their interest to like pursue STEM subjects in the future. And with that, thank you.
Thank you.
All right, let's go ahead and open it up for questions.
Yeah, go ahead.
So is this something that you think will be implemented to lower income households that we can afford all these chemicals, and being able to allow the students, or not even colleges, but schools in general, and allowing them to actually learn and experiment with it?
Yeah, definitely. And I had initially envisioned it for the purpose of being not necessarily a replacement of like actual hands-on experiences for kids, because I do think that I was a physics teacher before going into academia, and I really do think that like actual hands-on experiences with those are very valuable. But for students who don't go to schools that have the facilities for this kind of thing, or teachers who don't have the experience or expertise to kind of lead them through these kinds of experiences, I think it would be highly beneficial for them just to be able to have that kind of practice. And it is actually available on the Oculus or the Meta App Lab for like anyone, to purchase. So it's something that I wanted to be out there for people to use. I still work on it, but yeah, it's mainly, again, I want kids to be able to use it for it. Initially, I meant it to be for like kind of the upper middle school to high school age, but I do know, like, a higher ed, like to do that kind of stuff too.
Is this app available for purchase?
Yeah, it is $2.99, but I'm happy to give it. I know. I'm happy to give anyone a free key to it, just because it feels fun giving out free thing.
What is it?
What's that?
What is it?
Sorry.
What application do you use?
What application? Unity 3D.
Oh.
Yeah. I mean, it could have been done with Unreal as well, but Unity is what I know best.
Just curious why the $2 and.
Yeah, so initially it was actually $1.99, and then my wife was like, my wife was like, $2. This is like not that much, and I was like, yeah, that's true.
So this is, you monetize it for yourself, not a student income.
No, right, yeah, it comes back to me. I mean, this is in the weeds, but I basically get 66% of the sale, and 33% goes to Meta and their takeover of the portal endeavors. Yes.
Any of the participants have used VR before?
Yes, there were a lot. Actually, I don't have the data.
Because that might explain some of the behavior. Maybe a participant who is the first time to use VR, because he's just trying to see how things work. That might explain why they were throwing things.
Totally.
Yeah,
Absolutely. That's what I was curious about with the looking at the correlation with the, if they had a very high level of familiarity with VR, then I wanted to see if that would have translated to doing more of those types of things. Also, there was, I forgot to actually mention this, but in the flow of the study, there was a 5 minutes kind of like training session that I would lead them through, where they would just get used to the controls and kind of do stuff. And so I was hoping to mitigate some of the, experience with VR stuff in there. Yes.
I just have a follow-up question about the 5-minute activity video. So is that all it's for that's before the kids use the gear? Like what other things to do before the app was implemented?
Yes, exactly. This was all the instruction that I gave them before doing the chemistry lab simulation. So yeah, I didn't mean it to be like a full-on, like pre-lab kind of thing that a student would usually go through, but it was the purpose of it was to try and give every student sort of a baseline understanding of what safety behaviors we would typically expect.
And that was only focused on the content, right? The safety thing. Comes to that. It's nothing about the technical training on using the VR headset. So what do you do to teach the kids how to use the VR headset?
So during that 5-minute section here, I would have them be in the experience. They would be holding the controllers, and then we'd go through sort of almost like button by button. Like this is how you teleport, this is how you move forward, this is how you turn, this is how you grab things. Let's practice grabbing it. Okay, this is how you would. I forget, there was a special button they would need for like doing other things, and so I made sure that they do that. But
like a live demo, and then like letting them do it, showing them the boundaries and what happens when you exit the boundary, like that. It's simple.
All right, so we don't have any more time for further questions for Elliot, but let's give Elliot a round of applause.
thank you.